Okay, testing 1, 2, 3, testing. I hope this works now. Okay. Good day, everyone. This video will be discussing our module 10 for CE324 titled numerical methods. Na to. Topic for this video will be numerical differentiation. Okay, this is module 10. Short lang na kwanda ni before ko mo storya. I didn't prepare this PowerPoint presentation. Okay, I'm not very used to discussing things via PowerPoint presentations. Naikuan line na instructor naghimuan eh. Basically, I'm just doing a voiceover for this. I'm very used with sa na magod ko na handheld na pen and whiteboard sort of thing. So, please bear with me na lang if dili kayo ko if I cannot explain things kayo. But anyway, if you have questions, pwede mo ko nyo makontak anytime. No? Lang ko. Nagang lang ko daan. But anyway, just a short outline ani atong diri presentation. This presentation will contain an introduction to numerical differentiation, the equations to be used in this, and of course, na certain topic ani siya na unequally spaced derivatives, and we're going to be discussing some examples sa dayon. Okay? Announcements, sige lang. Magkuhan lang ko mag-discuss istorya rata na maghimo ra mo kog mga posts if ever I have some announcements to make. Okay? Okay, so numerical differentiation. Sige, personal siguro niya ni na definition. Calculus is the mathematics of change because engineers must continuously deal with systems and processes that change. Okay, so very managerial ang ang pag-define ani. It's okay. Engineering also involves management. So, calculus is an essential tool of our profession. Okay. Mathematically, the derivative, which is a fundamental vehicle for differentiation, represents the rate of change of a dependent variable with respect to an independent variable. Okay? Sige, I just patch magyapon siya explanation. I just want to add something na lang ano siya. When you say derivative, you're basically talking about the slope of a tangent line to a curve at a point. Okay? Slope of a tangent line to the curve at a point. Slope of a tangent line to the curve at a point. Okay? I-search nyo sa Google nga nagyapon na mo na. Anyway, there's a multitude of meanings for derivative, but I'd like to hold on to that na line. Okay, magamit man ta na siya niya. Okay? For now, ato lang sa na siya. Just hold on. Slope of the tangent line to a curve at a point. Okay? Sige. So, natay din niya. Short lang na din ni. 3 figures. ABC. But I'd like to start with C. Okay? I'm just I'm just discussing this based on understanding. It's not my presentation. I'm just using this. We have X and Y axis dire. We have a blue na curve din eh. Our curve is blue. And we have a condenda ni kanang a tangent line ano niya sa isa ka sa point. Okay? Now, the point that is located sa curve is right at xi. Atong niya ang x coordinate niya, ang y coordinate ano niya din diri is kining f prime xi. Okay? Muna siya ang atong ni y coordinate niya. Now, this point diri, if ato na siyang ipadayon og dito, extend ang atong tangent line, it will have a corresponding na ni slope niya. Okay? Siya rise over run yun. Okay? So much for figure C. Let's try to take a closer look at figure C daw ko no. Okay? In any case, that's figure B. Closer na siya na a look. So we have something like this then. Siya ganang gipang add din eh. Now, this is the point. Kaning point behind ani siya. I don't know if you can see my cursor, but kani siya na point diri sa xi, fxi. That is the point natong gi-refer aning kang C. Okay? Na din siya i-condenda ni. Na siya ka ng second na point, which is moingon din ka na, di ba sir, tangent line man na siya? Natikon din eh. Nakoy gusto isulti din eh. Well, another thing, nagingon din na calculus is the mathematics of change. Now, na-change ni gamay, butang ka ng natay sa ka-function, na-change na gamay, or mo change na dako. Ba? Mo yun ka ng changes could be infinitesimally big, infinitesimally large, though kay sa tanan, infinity ang pagkuhan ng change na niya, or it can be infinitesimally small ang change niya. Okay? So when you say ganang gamay ray kayon change ana saya ha, it only means na more it's basically the same, okay? It's basically the same. So atong istorya diri na change, ba? The word change. It's very small diri. So small that can be said na lang as dx na lang siya or delta x, ba? Very small lang equation na increment. So what was kwan gyud kanang figure C, what was originally a tangent line suddenly becomes a second line. Kido naman siya kabuk points. Pero gamay lang kaayo. Ba more siya kanang kwan kanang gilalisunon lang siya na tangent line nag-stretch lang gamay nimo niya nimo rin siya kwan then second line. But anyway, it's a line look ko stricto na to siya istorya, it's a second line. But when you take a look ana siya sa dako-dako nako ang range, it's a tangent line. We're just making a very small na increment ana niya change, which is delta x. Okay? If you're asking me unsa na siya gamay na putang paraning ko na kaning delta x, it's like nagluto og spaghetti, you're cooking the sauce, you're taking a kuan lang kanang gamay na kuan na kanang murag kanang kuha lang nimo gamay sa ka-small na teaspoon para lang matilawan bitaw sa sauce. That's just a very small change nga na siya gamay. So basically, this is a tangent line that's a second line kung tinuod kung stricto na tong storya. But anyway, muna siya nga atong pandin. Okay? Calculus is the mathematics of very small changes, but involves very small changes sa delta x. Now, if nani siya small change na to delta x, kani siya it basically means na atay xi muna siya tong first na coordinate, ang second coordinate niya xi plus delta x. Muna siya nga tong kwanenda niya yang change na silbi. Okay? Sa kwanenda xi plus delta x. Og kung masturyan tag y sa dana siya, it's basically kuan lang din. F of xi plus delta x. Muna sa ni siyang kuan na corresponding na delta y. Okay? Basically, delta y is just difference between kaning kuan f of xi plus delta x minus f of xi. Okay? Mo siya minus kani mo kuan mo sa delta y. Okay? So delta x pa na delta x ya pa. Well, anyway, that is so much for figure B. Figure A, ato ng figure A is just basically an expanded na kuan. Figure B niya. What was once a second tangent line became a very small second na line. Okay? But gamay raman kayo siya. That is the nature sa tuang numericals. We're dealing with approximates po. Okay? Ang calculus sad, ba? Natin mga incremental changes lang i-apply sa tuang functions. Okay? Muni siya. Balik na itong gingon ganiya. Kung ipagbalik ko gingon ganiya rather. Slope of a tangent line to a curve at a point. Our point is, kini siya, xi. Our slope is delta y over dx. Okay? Muna siya atong kanda ni. Slope of a tangent line. Atong tangent line na atong line, which is tangent, is also a second line yapon, which is kini. The points that connect xi and xi plus delta x. Ang slope ana niya, I don't know if this is Leibniz or kuana. Newtonian notation. But anyway, this is delta y, delta x. This is dy dx. Okay, that is the derivative. When you say derivative on your slope, rise over run. Okay, our rise here is delta y, which is technically just equal to fxi plus delta x minus fxi divided by ang atong run din there, which is just delta x. Delta x, by the way, is the space atong duha ka numbers. So, ano siya? That is the derivative lugar at that point xi. Okay. Short note on accuracy then. The accuracy of a finite difference approximation depends on the accuracy of the data points, spacing between the points, and the specific formula used for approximation. Okay. By the way, kani siyang atong kwan din eh. Kanina stage atong numerical differentiation, delta x is assumed to be equal na space. Okay. Sige lang. Continuing on with numerical differentiation. A function to be differentiated can be given as an analytical expression or a set of discrete or tabulated data points. What does this mean? When you say analytical, ganun expression din yan. Analytical na mathematical expression. Sige ka nang kon lang ka dali mo sabtan ka ng well-defined na equation. Okay, well-defined na expression. Say x cubed or sine x or e to the power of 2x, diba? Dali raman kayo na siya makuan, mahunaw na to musto ka analytical na mga expression. Say kini siya sine x. What is the derivative of sine x? Is cosine x, diba? When you're saying e to the power of 2x, ang derivative ana siya kay 2 times e to the power of 2x. Okay? So when you say x squared, derivative na niya is just 2x. Those things, kato si e to the power of 2x, kato si x squared, kato si sine x, those are what you call analytical expressions. Kung na siya, kanang well-defined na siya na equation. Okay? Which belongs in the halls of mathematics. Abstract mathematics, to be kuan lugar sa in particular. When you say abstract, that is kuan sa na. That's not real life. Okay? Now, kita mga engineers man upuhon, so you'll be dealing with real life problems. True to life na mga problems that ito actual situations. Good. Now, in those actual situations, you do not have formulas for that. You will be given data. However, namoy data na, namoy readings like pareha ng kono. Say, let's say, kuan na, you're a mechanical engineer and isa din ka kuan you're trying to extract data like gusto ninyo kuan approximate ang acceleration lugar sa isa ka car na inyong gi-design. Diba? But you can only record speed. Let's say wala kay machines lugar para maka-record ng acceleration. The only thing that you can record is just speed, velocity. Diba? Velocity excuse me, is the derivative of displacement with respect to time. Nga kung si velocity atong storyahan na sa dayon din saan na ito pagkuha sa acceleration kung velocity ra atong data. Atong unaw din acceleration is the derivative of velocity, which is the derivative of our displacement with respect to time. Okay? So you could say na dito, but di ito mag-storyahan ng kwan. Acceleration is the derivative of velocity. If you have the data for velocity, you can estimate the acceleration dayon. And this is the reason why na take on numerical differentiation. This is the motivation na siya. Okay? So much sa kung konstruct din when the function is given as a simple mathematical expression, the derivative can be determined analytically. Diba? Kung itong ginanaw sa inyo ganyan, itong e to the power of 2x, pwede siya may mukuan, derivative niya ay 2 times e to the power of 2x, or sine, derivative niya cosine. Siya examples din x cubed, ang derivative niya 3x squared, sine, kay cosine. That's good. But when analytical differentiation is difficult or not possible, then we can use numerical differentiation. Now, what instances, by the way, analytical differentiation is difficult or not possible? Be difficult lang to siguro sa exam na yatag. Okay? Yeah, it's not fun. It's not impossible. It's possible, but it's not. But it's just difficult ng lugar. So gusto niyo may compute ang derivative ato niya, you can just approximate its value na lang, di ba? But anyway, ako ipangita magyapon ng exact answer ato. So there's no other way around it na lang. Okay? But anyway, muna siyang kwan. Now, when the function is specified as a set of discrete points, ba? Kana siya, wala siya kanang actual good na mathematical expression, just a set of points lang. Differentiation is also done during using a numerical na pamagi. Okay? So, when we're talking about numerical differentiation, again na siya, three things you have to keep in mind. Okay? You have the forward difference, backward difference, central difference na mga kwan manners ano niya. Okay? Basically, kung naman ni siya, na kanang three ways around sa isa ka butang na compare lang dayon dani kung sa kalainan na nila. Now, we're talking about aning three approaches. In these approximations, the derivative at xi is estimated from the value of the slope of the tangent line connecting 2 points, basically. Okay, so story aning forward difference, a forward finite difference. Okay. Now, nani siya gikuan din eh. Let's just say na kani siyang kon din eh, we have curve din eh. Everything that's black, sabi, kani siyang black gani siya, that is true lugar na recording. Huwag na siyang nasa actual na kon phenomena. Ya kani siyang red diode, this is our way of kon lang going to that true na value. Di man na ito makuha ang tinuod, so muna siyang mga approximate din ta. Okay? Now, you have to check kuanan ni. I have to observe ang kaning kuanan niya, itong figure din ni. Forward finite difference. We have 3 points ani sa yabi. Ang atong first point din ni kay kani sa xi. Diba? That is the kuan sa kanang silbi. Ay na may apunte kuan. Let's say nagapunte data na si xi minus 1, xi ug si xi plus 1. Ito mga kuan na recorded na data. But kani siya tong katanon, gusto na to i-solve ang derivative at xi only. But we're giving 3 points din eh. Now, kani siyang kuan, when you say kaning black gani, this is the true derivative. This is the thing that we can never reach. Okay? So what we do, we just take the next best thing na lang. Deal with what we have na lang dayon. We have data naman. Diba? So muna siyang mag-kuan din ta, mag-approximate din ta na siya magpatag kaning atong red. Kani siyang red na line. Muna siya itong gusto i-achieve na lang rather. If di man ito ni makuha, kanina lang. Na siya difference gamay, but it's kuan. Can be small or tolerable. Ba? If na gamay ra kayong kuanan niya, then why not? It's good as the kuan the true thing ba? Kahit sa magyapon na siya. Di na to makuha ang actual, but makuha na to ang second dull na lang. Silbi. Now, ang kuan ni, when you say forward gani finite difference, it basically involves 2 points din eh. Kini si xi plus 1. Not much action for xi minus 1, okay? So, ang iyang movement, gikan kang xi, paingon sa kang xi plus 1. Now, for backward finite difference, everything that I've said atong ganiya, but ang kuan lang ani siya kay panawag siya, pabalik siya, pabackward ang atong style dili. Kanta ang xi, not much action for xi plus 1, gana xi, central niya, panawag din siya ng xi minus 1. Okay? And then, adin ni si kuan na sad, si central finite difference din dili. This is the true derivative gyapon. Approximated derivative niya, in this case, we leave off the central na lang. We'll just use the left and the right na lang na kwanta ni points niya. Wala kayo yung action, ikan kang central. Okay? So, na siya mga kwan din eh. Muna silang mga laylay nila ng mga batasan. Now, nasa ko gusto i-kwan sa diri, from experience naman sa sig solve, there is a difference din eh, di ba? Naman siya kang diferensya. Ano man? Unsa man ang atong diferensyada ni sir? Kani siyang space, kaning angle between ani ni kwan, true derivative ug ni approximated derivative. Can either be positive or it can be negative. Okay? Depending on sa atong kwan na. But anyway, sige lang, makuha naman na, ma-observe na to na siya sa mga actual problems na itong i-discuss. Okay? It can be positive, it can be negative. Balik na tayo yung slide natin, okay? Amo lagi ni. XI o kuan, kani siya mga points na madula kayo for forward difference, si XI, XI plus 1. For backward, XI minus 1 ug si XI. And kuan yun. Kani din si xi minus 1 of xi plus 1 din for central finite difference. Okay? The equations, we have the first derivative, second derivative, third derivative. Na siya mga errors dayon. Dili lang kita mag-discuss kay ano niya. Sige lang, ako lang mo ingon lang gyapon something about na later on. Now for forward difference, natay mga kuan din equations ani siya ha. But basically, these equations have been derived using kuan sana itong fundamental na theorem sa derivative. Okay? Less itong fundamental theorem of calculus involves integral. But katong yung katong yung definition gid sa derivative, itong limit theorem bitaw. Man siya, naman siya dito man na siya mag-derive. Anyway, wala man kayo na tatgaling na I don't think this presentation contains any thing about sa derivation niya. I'll just magbutang ko dito sa comment o kanang sketch na yun sa pagkuan na. Okay? Yun sa pag-derive ng mga expressions niya. Well, anyway, kani siya din ni H is the spacing between the points. H man siya, consistency H na so meaning when you say consistent diri, uniform spacing ang atong data. Our data is uniformly spaced. When OH means error is in the order of H, OH2 means error in the order of H2. Okay? Sige lang. That's error analysis naman ni siya ang kanina portion. Ako lang siguro na siya insert dito sa along with sa pag-derive na niya. Okay? Let's try out an example. Consider the function f of x is equal to x cubed. We need to calculate its first derivative at point x is equal to 3. Numerically with forward, backward, and central finite difference formulas and using points x is equal to 2, x is equal to 3, and x is equals to 4. Compare the results with the exact analytical derivative. Okay? The solution. So x, 2, 3, 4. So natay f of x, x cubed. So 8, 27, and 64 din na Kani siya ng mga numbers by the way, again, put rin siya din eh. Let's just pretend na wala ni siya. Atol siya nag-test lang ta diri. These are the actual na makuha na itong actual na values niya. Compare na to siya atong numerical na methods din eh. Anyway, if we can observe diri, difference ang spacing na niya is just 1. Okay? The difference ni 2, 3, 1. Difference ni 3, 4, 1. So, h is equal to 1. Okay? Evenly spaced siya na data. Now, approximate ano niya na value using forward difference. Kato, equation lang. Plug in lang niya mga values in there. You'll have 37 for forward difference. Backward difference, you have 19. And central difference, which is equal to 28. Okay? Started yun na itong icon na. But anyway, tana, you observe sa nation ng mga numbers. Okay? Try to remember these. 7, 19, and 28. Ang exact din niya, by the way, is 27. Okay? 27, 27, 27. Let's, sa 27 that is the true value. Okay? Muna siya itong true derivative. Muna siya itong approximated. So, ito na siyang isolve na yun. excuse, error is around 37%, 29, and 3. Natin mga kwandanin, nabantayan ng mga pulga, ron sa pa, di ba? Natin observe din na stuff. Makaingon din mo na, pasig central difference ka ta. Ba? Kamay makig-error, sir. Or ang backward difference ka. Kaya mas gamay siya kang forward difference. Taganan kang forward difference kay. Kuan man. Dako kayong error. Now, you have to kuan sana. Try to observe these. Balik daw ta sa kuan. Itong original na figure din eh. Okay? Sige ito shot. Wala na ko. 37, 19, ug 28. Okay? Forward difference, 37. Okay, 37 ug 27 natin. Print siya around 10. Diba? So, sobra siya, pinapositive. Si kuan, si forward difference. Around 10 pag yun ang kuan niya. Diba? So, if minus siya mo siya 10, makuha ni mo true value, makuha ni mo true derivative. Approximate mo na to, 37. So, we have to take note of that. Diba? Ito siyang unaw-unaw. Now, kanina sa din kang backward finite difference na difference siya around 19 man siguro to siya, 27. Diba? Siya around na error pila man na siya, 8. Okay. 8 lagi. 8 siya. Pero panawag na yun. Diba? Kasi nga na kon error. Panawag na po siya. I mean, kulangan siya. Na 19 plus 8 dayon you have the true value na sad ba? You have 27. So na-shake on na. So natay dungag na siya dapat. Yeah, kanina sa din si central finite difference na po na siya difference siya 28 ba? Sobra siya gamay. No 27 nung tatuban niya, 28. Si sobra mga ligas isa, 1 point lang. Da? Po at least dul-dul siya. But ang atong kwan din concern din siya, what does this mean? Na may siya mga laylahi na kwan. Pamatasan. Meaning ano saya na laylahi gini sila kwan na for each na kuan technique there are advantages and disadvantages ano saya ha. Okay? It's not all the time sad na si backward mo yung lamang compared kang forward. Unya si kwan din central din ang champion. Depends kung sa atong itsura sad sa curve. Okay? When you say x cube gani, ang itsura sa itong curve na siya kay more siya kanang steep kayo siya bitaw. Hinay kayo siya sa sinugdanan. Pero once mo dako anong numbers niya, value ng x, mo skyrocket na din siya very quickly. More siya kuan. Pares sa ni exponential. Ba? So, muna siya inyong kuan ni keep in mind. Ano niya? Pero basin di ay, when curves gani kay butang ta dili siya ingat to itsura exponential butang ta kanang mura siya tambok mo ta ng curve niya mura siya kana say kuan kana especially mga cube root bitaw ana mura siya kana flat din siya sharp kayo sa sinugdanan niya pag-abot din sa unahan din kay mo hinay na din ang sakan niya basin mas pabor na si kuan forward finite difference. I'm not really sure but kanisha these differences kuan values na ng gawas it only means na per approach na siya kuan there's a difference na siya so you have to keep in mind when you're dealing with data. Okay, that is most especially kung kuan gyud taon sana kanang we're dealing with sa data pohon especially sa inyong thesis. Okay, so you have to keep that in mind na magkuan mo. Nga na ang inyong kuan approach ani sila. Okay? Mumagin siyang kuan ang use good sa inyong numerical methods. Thesis man gini siya. Nakatong error by the way. Dali na siya contained. Okay? Itong mga difference niya 10, itong 8, negative 8, itong kuan, dali na siya. Okay? Nakabutang na siya sa mga errors. Now, consider balik naman ta din Anyway, naumantana na portion. Okay. How about we consider the same problem, but let's use very small increments. We say not take one na points na x is equal to 2.75, x is equal to 3, and x is equal to 3.25. So, the x din yan lang nang cube da yun, para diretso na. But anyway, atong spacing din will be 0.25 na sad. Oh. Let's try to sana go with forward difference. Unsa to makuha na siya dahil 29.3125. Backward, we get 24.8125, and for central difference, we have 27.0625. Exact numbers is 27 yapon sa tanan. Error ana niya is just around 8.565, 8.102, and 0.2315. Okay? So, man siya mga errors niya. Gamay lang kayo. Now, what does this mean, Asad? The more na mas closely spaced na natong data, the more na mas makuha na to accurate ang kwan. Okay? Ato ang analysis diri. But it's not always the case lugar kung magkwanta ka na mag-measure tag mga stuff. Okay? Like katong gisulti niya na velocity. Bas hindi ang pares ato niya ay musturya lugar ta na i-calculate niyo si acceleration. So you're dealing with velocity na siya pares na time. Ba? Say 1 to 3 1 2 or 3 seconds dako na kay siya difference. Sumutong para tong ganiya. Dako na kayo, but say you're counting things, you're recording things to the millisecond nga na accuracy ang atong istoryahan. Na nakadug-o lang inyong mga points, di ba? Mas accurate na din siya. So kani siya mas ma-appreciate na ninyo na siya ponpon when you're doing with thesis. But of course, mas lisod na siya himuon in real life, di ba? Di ba ninyo na makount sure na 1 millisecond, 2 milliseconds, 3 picoseconds. No human can achieve nga na nakon. Oh. So, ana na siya. Okay? So, I'm trying to relate this sa kon kanang actual na mga uses ana niya ponpon. Sa especially sa data cultivation because there again yung ma-appreciate ang beauty sa numerical methods. Okay? Now, so much for that. Let's move on to derivatives of unequally spaced data. Data from experiments or field studies are often collected at unequal intervals. Mo gini siya. Dili sa to pwede na magkonta equal tag mga kwan ba pila ka seconds dili man sa na possible pod. So there are times sad na through human error nagyapon na mitabo na dili na to siya makuan ma-achieve ang na to. Robot siguro mahimo but dili man ta ka-afford tanan og robot. So mag-record ta manuman no. Sometimes maglaylay ang interval. Kay tao ra man ta, di man ta perfecto. So muna siya ingon ana. Ba? So we have a separate na treatment ani siya. One way to handle this is to fit a second order Lagrange interpolating polynomial as in our curve fitting lesson. Okay? Wow, grabe siya ka. Sige lang, I don't think ka-contain ng kwanda niya, derivation din sa itong presentation. But anyway, I'll try to find the ikuan na niya na derivation kung saan pagkuanan siya. Kani siya, marig na siya something that involves Taylor Kwan series. Sige lang, ako na siya ikuan. Paitam tani pagi. Some important advantages ani siya include can be used to estimate a derivative anywhere within the range of 3 points. Okay? Anywhere. Sa interpolate lang siya. Yung sa interpolate gani, nasa sulod sa kwan. Around anong 3 points na kwan. Wala siya nilocate sa outside. When you say outside gani, that's extrapolation na, okay? We're dealing with interpolations din. The points need not be equally spaced. Okay, that's very good. Ba? This is much more humanly possible. Mas kwan siya. Mas human friendly ni siya. The derivative estimate is the same accuracy as the central difference approximation. Okay? Derivation sa niya, it also involves central difference approximation. So muna siyang mas kwan siya na kadugo ra na yan. Okay? Let's move on to kwan din sample problem. the heat flux or the temperature gradient at the soil-air interface z is equal to 0 can be computed as follows. Q is equal to negative Kp K rho C times the differential of temperature o kuan dayon ganing si depth, okay, dz. Ano na siya? Heat flux, temperature gradient, okay? Where Q is equal to the heat flux, ang kuan na niya, ang iyahang sa unit niya is watts per square meter. K is the coefficient of thermal diffusivity in soil, which is approximately equal or assumed to be 3.5 times 10 to the power of negative 7 square meters per second, and rho is equal to the soil density. Rho. That is equal to 1,800 kilograms per cubic meter. And C is the soil specific heat, which is 840 joules per kilogram times degree Celsius. Okay. Now, say na lang tayo kung din natin data din igatan. We have 3 points. We need to use numerical differentiation to evaluate the gradient at the soil interface level using this estimate to determine the heat flux into the ground. So natay recordings na ni tulo ka buok. Natay O, natay 13.5, 0 to 13.5, 1.25 to 12, and 3.75 to 10. Okay? Kanya itong kwaon kanya si dt over dz. That is the derivative lugar atong silbi, derivative ba niya itong function din eh. Now, singa na dayon, solution niya, estimating the first derivative at x equal to 0, that we have atong temperature din eh. This will be xi minus 1 is equal to 0 is to 1. That value. Xi is 1.25 is to 12. 3.75 is equal to 10 atong forward. Okay. It's backward. This is central. This is forward. Okay. We have this equation. Just follow the colors. Sada kayong colors din. Nakaputang mo. Yan na naman na siya. Para masyada man na siya. Actually, ang color coding ano niya mas if dili ka mga ka-master bitaw na mag-memorize ang formula, if you do this, mas sayo ni siya na way. Okay? Just plug in everything and itong makuha dayon kay negative 1.33 unit niya kay Celsius per centimeter. Okay? Rate of change of temperature with respect to soil depth Z. Okay. Estimating the heat flux Q. Na naman tayo dt, muna siya itong dt over dz. Okay? Hindi mo to natin temperature din over z. This is temperature, this is depth. Estimating the heat flux Q. Balik na itong original equation. We have this naman, so hindi na kasi nga nakalisod. Plug in the equation, and then masolve na ito dayon si Q. Makancel out mo ng mga kondan eh. kg, pak, mawala. Kani siya, mawala gyapon. Kani siya, kani mawala ni. But kani we have M4, so kasi M squared gyapon mabilin, which is kani din. Watt per M squared. Okay? 70.56. So, with that, dayon, that will be all siguro para sa kanya discussion. Now, announcement, sige lang. Dili mo niya yung announcements. Ako rin sige borrow na kuan. PowerPoint presentation. Sige lang kay mag-kuan naman kuan na mag-post ka. Post naman ko if natin mga kuan. That will be all. If you have any questions, concerns, clarifications, or violent reactions, I just hope so wala. Just feel free to comment or send me a message. Thank you for listening. Thank you for your time. God bless.